In this video series, we're going to take a look at calculating the change in momentum of a body. What we're told here is that there's a hockey puck, it's 163 grams, which is the mass, and we take note that it's grams, it should be kilograms, so we're going to have to convert that. And it's the hockey puck is the victim of a vicious slap shot, it should be slap shot, as in hockey, the goal, and it misses the net. It heads to the right and hits the boards at 45.2 meters per second and rebounds with a speed of 5.2 meters per second. So this is the V0, and this is the V. We want to know the change in momentum of the puck. So our picture should be a motion diagram. And we're told it heads to the right and hits the boards. So the boards are over here. So we've got the right, which is positive, and we've got the left, which is negative. So the puck is moving this way at 45.2 meters per second, and that's the V0. And then it bounces off and heads in this direction, and that's the V, which is also 45.2 meters per second, but it's in the opposite direction, so it's negative 45.2 meters per second. And we're asked to calculate the change in momentum. Well, the change in momentum is m delta v. Our mass is in grams. It needs to be kilograms. So 163 grams times, see grams on the bottom, kilograms on the top. 1 kilogram is 10 to the third, or 1,000 grams. Grams cancel. And since it's 10 to the third, we move the decimal place 3. So it is 0.163 kilograms. So we have 0.163. And now we have delta V. Well, delta V is V minus V0. The final velocity was minus 45.2 minus the starting velocity, which was 45.2, which means the change of velocity is negative 90.4 meters per second. And that's an interesting thing that we find, that when something bounces off something else, that the change in velocity is twice as large. That's fairly common. So now we want to do our power of 10 estimate. And so we've got this number, 0.163, which would be 0.2. And negative 90 to one digit would be negative 90. And so that's going to be, well, negative 90 times 2 would be negative 180. So this is going to be like negative 18. So we're looking at an answer of about negative 18 kilogram meters per second. We could even have said this was 0.2 and minus 100, which means we'd have an answer of about negative 20 kilogram meters per second. Not squared meters per second. So then we plug this into our calculator. 0.163 times a negative 90.4. And that gives us negative 14.7352. Negative 14.7352 kilogram meters per second. That's our change in momentum. And if we compare that number, minus 14 is about minus 18, similar sizes. So our answer in the formula and our power of 10 estimate kind of agree. So this is the value of this is our unrounded value. And now this one had 3 digits in it, and this one has 3 digits, so we can report 3 digits. So our change in momentum is negative 14.7 kilogram meters per second. 3 means we keep that. So that's the insignificant digits. And now we're going to put it in scientific notation. So the change in momentum would be negative 1.47 times 10 to the 1 kilogram meters per second. So going back to check, we've got our labeled picture. We identified the givens of mass and the velocities. We identified the unknown, which was change in momentum. We didn't have to solve. We did have the equations. We used 2 of them. We substituted the values. We recorded the unrounded answer. We put in our units with kilogram meters per second. We did our power of 10 estimate over here, and we used the significant digits, put it in scientific notation, and then, oh, it's a good thing we're checking this. The SI prefix, 10 to the 1, is not one of our prefixes, so we're not actually going to put it in the scientific prefix. So those are our 3 final answers. In the second video, we'll take a look at what happens when there's uncertainty. And again, this first part is worth 18 out of the 20 points of the quiz. And the remaining part is 2 out of the 20 points of the quiz.